All right, good afternoon. Thank you all for coming in today for this talk. I promise you that you're going to go back with at least one new thing that you learned from this session. So that's a promise from my side. What I'm going to be talking about today is PySpark and Dask. And PySpark, as you know, is this data processing engine, which a lot of organizations have been using for a very long time, and Dask is kind of the new kid on the block, which people seem to have been talking about, but nobody's using it that much of late, and I'm here to talk more about it. With that, my name is Vaibhav Srivastav. It's difficult to pronounce Vaibhav, so you can call me VB, as in Visual Basic. I'm a data scientist who's based out of India. I work for Deloitte Consulting. I basically architect machine learning workflows on Google Cloud Platform and do strategy and analytics consulting for our clients in US and in India. Yeah, so enough about me. Let's talk about you. So how many of you have worked with big data workflows before? Yeah, be proud about it. That's good. How many of you have heard about Apache Spark or used Apache Spark? Oh, that's a lot. Are there any who've worked with Dask before? Okay, yeah. So we have a fairly mixed group. This is what I wanted. Great. Right. So for those of you who do not know what Spark is a general purpose distributed data processing engine, right? Which means that whatever data you throw in at it, it'll process that given whatever code you write, whatever functions you write, whatever user-defined functions you write, and it will process it and put it in the format you want. It's basically an ETL tool. And it has a lot of abstractions built on top of it. So for example, you can use Spark SQL, you can stream data using Spark, you can use the machine learning library within it, and you can also use GraphX, which is for graph DBs as well. Spark is like multifaceted in the sense that it can support a lot of different languages. So it supports Java, it supports Scala, it supports Python and R, and they're building bindings for Julia and all the other libraries as well. So Spark's been around for a very long time. Now, specifically for us as Python developers, we use PySpark a lot. It's good. It helps us build our pipelines quite quickly. It's easy to pick up as well. But there are a lot of issues with that. One being is that when you write PySpark code, you write it in Python, but it's compiled into Java using Py4j. And I'll come to the issues that come to it, but just that conversion alone adds a lot of overhead to your pipelines. What that means is that even if I have to do a simple group by, on my Spark data frame, just the compilation alone or the transcompilation alone will take a couple of seconds. And couple of seconds is all right when you're talking about gigabytes of data, but when you're talking about terabytes and petabytes of data, that's hours, not minutes, right? Now, couple of other issues with PySpark, at least in my experience, you write some PySpark code, right? And just out of nowhere, you see Java tracebacks in Python code. I mean, what? And as if that was not enough, you have null point exceptions in Python for no apparent reason. And if you can see the traceback over there, it starts off with a Java traceback. I mean, not all of us are proficient in Java, right? Not all of us can go in and like understand Java code, Java tracebacks, Java exceptions, and so on and so forth. So how do we make the whole experience of building ETL pipelines more enjoyable, more intuitive, and more easy to debug? That's where Dask comes in. Dask was designed from ground up to parallelize Python ecosystem, which means not just your code, not just your existing code bases, but also all the new code, your machine learning code, your usual web server-based backend backend as well. So any and everything in Python can pretty much be parallelized with Dask. It has an extremely familiar API. If you've ever used pandas before, it's pretty much the same as that, right? If you've used scikit-learn, it's basically plug and play. It is, and this is the best part, because this was co-developed with pandas, scikit-learn, and Jupyter teams. It was built from ground up again to keep the user experience and the developer experience in mind. So it's not a information overload for you. Last but not the least, it scales from multi-core. That means your laptop to 1,000 of node of clusters. It can scale from your laptop to your supercomputers, to your Amazon instances or your GCP instances. It'll work, the same code. But you may ask, why Dask? I mean, why do I need Dask anyway? One, it is a scalable, it's a scalable pandas data frame. What that means is pretty much with the same code that you used to use in pandas, you can make a Dask data frame. So you don't have to go through the documentation again. I mean, not that much as you had to do for the first time in pandas. You can pretty much use the same code and then just be able to create a like a Dask data frame. So as you can see over here as well. One sec. As you can see over here, what I've done over here is instead of doing import pandas as PD, I've done import dask.dataframe as DD, and then I'm creating a data frame using dd.read_parquet object, which is saved in an S3 bucket, and then I can pretty much use the same syntax I was using in pandas, like df.groupby and get the mean and then like compute, right? So pretty much everything's the same, except now you have the parallelizability and the usability of Dask data frames. This is my favorite bit. You can parallelize your scikit-learn, your machine learning workflows with Dask as well. For those of you who've used scikit-learn till now, scikit-learn provides some inbuilt capabilities to parallelize your code, but it is limited to only 4 or 6 thread nodes, right? What you can do with joblib and Dask is pretty much use the joblib's parallel backend and use Dask as a task scheduler to parallelize your code and get massive performance benefits out of it. This is again an interesting bit. How many of us have coded in Python before, built some basic code, and then only to realize that particular code is extremely slow and does not scale well? This is a problem at least I face a lot in my work, right? So imagine you have a simple code base like this, right? Wherein you've got 2 for loops running, and you're running a function to compute some sort of result, and you're appending it back into an array. Now, if I was to optimize this without Dask, I'll probably put this into a list comprehension. I'll probably put a generator in there, and try a couple of different other things, right? But with the advent of Dask, you don't have to do that anymore. It's literally just 3 lines of code that you have to add. You have to put your functions, for example, the function f and function g in a dask.delayed object, and then you have to compute the entire results using dask.compute. This is literally the only change, and this will help you in getting massive performance boosts in your code bases. And if you this is something which is so easy to test out as well. You can literally just go to a Colab notebook and put in bunch of lines of functions and code and try this out. Not just that. Now I've been talking about Dask scales up quite well, right? Now Dask, because it doesn't have to transcompile any code to say Java or like any other language, Dask scales up quite well because it's natively written in Python, right? It scales up to 1,000 of nodes. It can work on Amazon EC2 instances. It can work on Google Cloud Platform, Azure, like whatever you think of. More than that, more specifically, the overload over here, or the task overload over here, is merely 200 milliseconds, which is seconds, if not minutes, in case of PySpark when you're running a workload on scale. Not just that, Dask scales up, that's fine, but it scales down quite well as well. What that means for us is we can run the same Dask code on our laptops, on our personal machines as well, and that won't slow our code down. But what that means is that there is no performance penalty at all. In case of PySpark, you would see that there are so many repercussions of running it on a single node, because your master node and all of your slave nodes are running on the same laptop, and that just causes a huge network overload on the laptop itself. That's why Dask scales up and scales down. So it's extremely useful for rapid prototyping on Dask, and then deploy it. So run it on a small chunk in your laptop, and then deploy it on the full data set on your cluster. More than that, I don't have to deal with Java null point exceptions. I don't have to deal with Java tracebacks. I don't have to spend thousands of minutes scouring over Stack Overflow, thinking about Java tracebacks. What does this exception mean? What does this library mean in Spark, and so on and so forth. And yeah, that makes me happy. Last but not the least, this is my favorite bit. Dask provides a really beautiful diagnostic dashboard. What that means is, when your code is running, while your code is running, you can actually see across cores. If you see towards your left side, you can see the number of worker cores, right? 0, 1, 2, 3, 4. You know that what your worker is doing and when, right? And what kind of processes are running over there. Not just that. It tells you how your overall cluster is performing, right? So how much memory usage is how much memory is being used by your cluster? How much CPU utilization is your cluster hogging? And last but not the least, it breaks your high-level functions down to fundamental functions and shows which of them is taking the maximum time. This not only helps you in writing better code, but also to optimize your existing Dask code as well. PySpark does not offer anything like that. This is like the full view of the dashboard. So anywhere that as soon as you run the code, you'll see that on the right side there are group bys happening, and across all the cores, across 14 cores, across 16 cores, your task is being split, your computations are being made, and they're all merged towards the head, as you can see over here. This is where the final result is then shipped. And then below, you can see how the entire task is split into multiple fundamental tasks, and how Dask optimizes them individually across multiple cores to be able to get the final result. Now, I've spoken enough and at length about how Dask works and why you should adopt it. But let me give you certain data points to back that up. We did some benchmarking on both PySpark and on Dask. So first one is quite simple. We took one single file which had 1,000 records, and we basically read them into a data frame, into a Dask data frame and into a PySpark data frame. What that resulted in was Dask took 1 second as compared to 11 seconds by PySpark. Then we thought that 1,000 records is something that we will probably never do in Dask. Then why not scale it up to 1 million records? What that resulted in was 1.8 minutes on Dask as compared to 2.3 minutes on PySpark. Then we went one step ahead, and we used the same 1 million records, and we tried to persist it in RAM, in memory, in our cluster as a pandas data frame. Again, what that resulted in was Dask being 1.6 minutes, Dask taking 1.6 minutes as compared to PySpark taking 2.6 minutes. Now, keep in mind that this is just 1 million records. When you're deploying it for your organizations, when you're deploying it at an enterprise scale, you would have roughly about 10 million records, 100 million records, in some cases, 10, 20 billion records. In that scenario, the difference would not just be a minute, it would be hours, right? If not days, depending upon the complex business logic you're trying to apply. Then what we tried to do was join two individual files, two individual data frames together and create one data frame within pandas. And this was all happening on cluster, right? Just bear in mind, for this analysis, we had exactly same clusters running Dask and PySpark so that we do not have any issues in measuring the time. And this is where Dask went down the drain. On PySpark, we got 5.6 minutes, and on Dask, we got 12.8 minutes. Upon checking on GitHub, this has now been fixed in the most recent version of Dask. The issue here was that since it was two data sets and they were on a totally different index, that's why Dask was taking a lot of time to merge them. But this has now been fixed. So you'll find massive improvements in the 12.8 minute case. But this is by far out of the 4 benchmarks that we ran, this is the only one in which Dask did not fare well. But on all the other ones, PySpark did, Dask did a phenomenal job there. Now, yeah, I mean, like we've been through the benchmarks, we've been through why Dask is the best, why we should use Dask in our workflows and why not. Which one should you use? The solution is that there is no solution for it. There are only trade-offs, right? What that means for you is it depends on what kind of technical debt you already have. Right? I won't say what kind of technical stack you already have, because the moment you add a technology into your stack, you're adding some technical debt or the other. So rule of thumb is if you're already on a Hadoop-based system wherein you have Hive tables and you have Pig workflows and Scoop workflows and so on and so forth, then you're probably better off using Spark and so on. But if you're running something from ground up, if you want to build and bake speed in right from the start of your project development, right from the POC phase, from the proof of concept phase to the deployment phase, use Dask. It's much better. With that, you may want to try it, right? Now, not all of us have access to a cluster at our home. We do not have access to cloud necessarily. And how do we run these benchmarks? How do we test out Dask? How do we test out Spark? Don't worry, I've got you covered. I've made these small nifty Colab notebooks through which you can literally just click on that and you can run your Dask code on Colab. I have taken care of all the other abstractions for you. So for example, I'm just going to quickly run this for you. So as soon as you click on the link, all you have to do is just click here, and it will connect you to a Google Cloud Compute engine. For those of you who do not know Colab, Colab is like an extremely useful research tool to run your Python code, and it gives you 12 hours of compute, and you can quickly write some Python code, share it with someone, and test a couple of things out, and save them to your Google Drive for reference as well. So over here, all you have to do is just run this cell. So let me run it. And it spins up a cluster with 1 worker, 2 cores, and 13.66 gigabytes of RAM. Now, there's a small bit here. So Colab does not allow you to expose or open localhost tunnels. So you cannot open the Dask dashboard, that beautiful dashboard I've been talking about since a very long time. I created this sort of a hack. What it does is it installs ngrok on your Colab instance. And with that, it exposes an ng-rock tunnel which you can access. So what that means is, instead of Colab saying, no, you cannot use Dask, you can now use Dask. And it's opening up. So you can see if I click on workers, task, system, you can see all my CPU percentages, bandwidth, and everything. And this is running on my Colab instance. So you can now do any and everything on Colab without wasting any money or like investing any money on it. And you can utilize the same thing. Last but not the least, if you're interested in PySpark as well, do not abandon PySpark. It's good for a lot of us as well. So I have built another Colab notebook which actually sets up a Java environment within Colab and lets you run PySpark on a Colab. So you can pretty much just run it. It installs Java. It installs PySpark, sets up your Java home variables, Spark variables, and yeah, it takes a little bit of time, but in reality, you can run your PySpark code and test, prototype, and so on and so forth. My recommendation to you all would be to, if you've ever written a pandas code, ever written a data analysis, ever done any sort of data analysis in Python, try to replicate that code into Dask and see what kind of performance boosts are you getting, right? If it doesn't give you performance boost, it's not the end of the world, right? You can always go raise a new issue on Dask saying that why is this not working, and better than just raising an issue, actually own it and start fixing that issue as well, right? And yeah, I mean, that's it. Try and learn Dask. Try and like spread the word of Dask around. Test out PySpark as well. I hope it helps you. I hope you learned one new thing today. Thank you so much.